Okay, hi everybody. I'm just going to quickly do a little video here over polynomial division. Okay, and now polynomial division can be done in a few different ways, well, a couple of different ways here. I'm just going to really focus on two. But to start off with, before I introduce like the long division method, I want to just take a quick look at regular old long division. Let's say that we've got 785 and we divide that by 3. Okay, so with regular long division, really what I'm trying to do here is put numbers up here in my quotient, and each time here I'm gonna put a number up here, I'm gonna multiply and then subtract, because my goal is to try to get rid of just subsequent placeholders, place values here. Okay, I want to get rid of the 700s, I want to get rid of the 810s, and I want to get rid of the 5 here. So what can I multiply by 3 to get me really close to that 7? And the answer is 2. And I'm going to put 2 up here. And I'm going to put it just above the 7 here. Remember, this is 700s, and this is going to end up being 200s. So when I multiply that out here, I'm going to put a 6 here. And this is really more like 600, but we don't typically draw those other zeros there. Mostly just to not confuse people, because there's some obvious questions that would pop up there that kind of fog the issue a little bit here. We just want to focus right now on just that placeholder. And then we do the subtraction. So 7 minus 6 is going to be 1. And then this is, we tell people oftentimes, just bring down the numbers here. But really what it is subtraction. 8 minus 0 is going to be 8. 5 minus 0 is going to be 5. And then we start the process again. And I look at the 3 here and I wonder, okay, can I take that 1 and divide it by 3? And the answer is no, I can't. And that's because I did that first step correctly. So then I draw back a little bit. Okay, well, can I take 18 and can I divide it by 3? And the answer is yes, I can. 6 times. And I put that 6 in the tens position here. That's really more like 60. Okay? Sorry, I'm going to see if I can fix. I don't know what happened there. So 6 times 3 is going to give me that 18, which really, remember, that was supposed to be 60, so this is really more like 180. And when I subtract, I should have put the subtraction up there, 18 minus 18 is going to be 0. That 5 minus 0 is going to be 5. And now I do the procedure here one more time. Think, well, how many times can I divide that 5 by 3? Ooh, this one's not so clean. 1 times 3 is going to get me 3. That's the closest I can get to 5. And I'm going to get 2 as a remainder when I subtract. So my quotient here is 261 with a remainder of 2. So if I multiply 3 by 261, I am going to get as close as I possibly can to 785. There will just be 2 values left over here. Okay, that's how that works. Now let's take a quick look at an example using polynomials here. Okay, and this example that I'm going to use here is based on a question that I just got recently. Let's say it's this one specifically, x cubed minus x minus 10 divided by x plus 4. So I'm going to put the x plus 4 out here, divided by x cubed. Okay, well, now, before I finish writing my dividend here, over here, when I did the long division, I'm basically worrying about placeholder after placeholder after placeholder. Well, with polynomials, the kind of the corresponding idea is going to be term with the highest degree. So I'm getting rid of the highest degree term and then the next degree term and then the next one as I go along this polynomial. Now I've got a cubic here, then I jump to a linear and a constant. I'm missing the quadratic, so what I need here is a placeholder, a 0x squared minus x minus 10. Okay? So now I've got my placeholder here. If the tens, let's say, were missing here, if I didn't have 8 tens here, it was just 0, then I would have had a 705. There would have been a 0 there. With polynomials, we don't typically include that term if it's not there. We just skip over it. Anyway, now what we're going to do is I want to get rid of this x cubed term. So I got to ask myself, well, what can I multiply by this to get an x cubed to pop out? Okay. Well, I can multiply that by x squared. X squared. And when I multiply x squared by my divisor, I will get x cubed. Now, remember, I have to multiply it by the whole divisor, so I got to multiply it by that 4, and I will get 4x squared there. Okay? Now, I don't really care. I don't really care about that little bit right here, I'll deal with that later. What I really care about is that I've got x cubed minus x cubed. Okay? And when I subtract, I'm going to get the x cubes will cancel, which is perfect. It's exactly what I want. And then 0x squared minus 4x squared will be negative 4x squared. And then, just like before, there's really going to be these 0 terms here. And then negative x minus 0 will be negative x. Negative 10 minus 0 is negative 10. Then I start it again. What can I multiply by x plus 4 to create this negative 4x squared? Well, negative 4x. And notice that I'm putting the quadratic term over the quadratic term, linear term over the linear term. Negative 4x times x will be negative 4x squared. That's beautiful. Negative 4x times 4 is going to be negative 16x. And when I subtract, the negative 4x squared terms are going to cancel. Negative x minus negative 16 will be 15x. One of the more common mistakes that gets made here really just deals with negative signs. Subtracting a negative. Okay, just be careful with that. And then negative 10 minus 0 here is going to be negative 10. Now, the degree of my divisor and the degree of my remainder here are the same, so I can keep going. What can I multiply by x plus 4 to get this 15x to show up? And the answer is 15. So 15 times x is 15x. Love it. Beautiful. 15 times 4 is going to be 60. And then I subtract. And negative 10 minus 60 is going to be negative 70. And so there's my remainder now. So my quotient was x squared minus 4x plus 15 with a remainder of negative 70. So what does that mean? Well, that means that I couldn't get x plus 4 to multiply out nicely to get this x, like I couldn't get a quotient here that made it multiply out perfectly to get my dividend. But I got really close. Okay, x plus 4 multiplied by x squared minus 4x plus 15 is really close. If I just subtract 70 from that result, then I get my result here. Now, there is another way that we can do this called synthetic division. Okay, and in synthetic division, what we do, and I'm going to rewrite this question over here. We've got x cubed minus x minus 10, and I'm going to divide that by x plus 4. With synthetic division, what we do is we really just focus on the coefficients. Because that's, even if you look over here, all of the work was really being done with the coefficients. Now, the cubes and the squares help me line things up. Okay, they also kept my focus on certain terms here. But I don't really need to write them if I keep my focus, and I can do that by basically splitting things up here. So what I'm going to do is I'm going to write out the coefficients here. Now notice there's a missing term. So when I write out the coefficients, I want 1 for the x cubed, 0 for the missing x squared, negative 1, negative 10. So there's my dividend. Now, my divisor is x plus 4. There are two common ways to do this. One way is to put a 4 here. Now, I'll explain what's going on here. So one way is to simply copy that number over, okay? And now what we do is that 1 drops down, we put a 1 here, and then you would go 4 times 1 is 4, okay? So you multiply, just like you did up here. Remember, when I put that x squared there, I multiplied, and then I subtracted. So what we would do here is, first of all, you got to bring down the 1, and that's just to start the ball rolling here. Then you multiply, put the 4 there, and then we subtract. So 0 minus 4, negative 4. Multiply, okay, to get negative 16, and then we subtract. Sorry, I should do it like this. And then we subtract. Well, negative 1 minus negative 16 is going to be 15. And then 4 times 15 is 60, and then we subtract. Negative 10 minus 60 is negative 70. And so how we interpret this is my remainder. This is my constant term. There's my linear term. Here's my quadratic term. And then I just put the appropriate signs in there. That was negative and this was positive. Now, another way that you could do this is normally the way I teach it here. Same setup, but instead of using positive 4, what I do is I change the sign here and I make that negative 4. Okay? So instead of subtracting all the time, I am now going to add because I've already incorporated the subtraction into here. So and just watch what happens. I bring down the 1 just like I did before, and now I multiply and add. Okay? And 0 plus negative 4 is going to be negative 4. Multiply, positive 16, add, and I get 15. Multiply, get negative 60, add, and I get negative 70. Okay, so basically I'm forcing the subtraction to go here. I think this way for a lot of people is a bit more user-friendly, only because even if you incorporate negatives in there, whatever, most people just are mentally more comfortable with addition than they are with subtraction. Really, I haven't done much to change anything, but it does give a bit of a nicer feel to the question here. And again, we interpret it the same way. There's my remainder, linear term, constant, here's my linear term, and then here's my quadratic term. Okay, so there you go. I hope that helps give you a little bit of an idea of how polynomial division works.